Welcome to the video for Investigation 2.5, Amusement Parker Movies. In this particular investigation, we were looking at the focus question of what strategies do you find useful to find solutions for linear equations. So essentially, with this investigation, we were looking at finding solutions, but we were also starting to look at what if we had two lines and if they intersected, what does that intersection point truly mean? So let's play around with that whole idea. In the following formula, give the fare F in dollars charged by two bus companies for trips D miles. We have transcontinental, which is the fare is equal to 15 cents times the distance plus 12 as the flat rate. And we have intercity express, where the fare is equal to $5 plus 20 cents per mile. So looking at this, we are going to just compare the two equations, the two situations, and solve for part C. So we're only looking at this part and our equations right here. So looking at this, what can always be helpful, especially when you're looking at two scenarios, is to graph it. So that's exactly what we're going to do. We're going to do a little bit of graphing. So I'm going to use some magic with this video software, so stick with me. I'm going to be magically showing various plots and that sort of thing, but let's get started with this graph. Here we go. We have our y-axis and our x-axis, and we have on our x-axis, let's look at our distance. So essentially everything's dependent upon that. So let's look at distances of 10. So say 10, 20, 30, 40, and so on, 50, 60, 70, 80, 90, and 100. And our fare, it looks like our fare might get fairly decent, especially if we have 100, because we're going to be looking at maybe 30 or so dollars, maybe $40. So let's also go up by tens, 10, 20, 30, 40. I'm going to add some labels. So we have miles, D, and we have fare in dollars. So there we go. Let's create a couple of points. So let's look at transcontinental initially. So I'm going to do transcontinental in green. So here we go. We start out, I'm going to erase that so I can actually read my equation. We start at 12 about, and we're going up 15 cents for every distance. So if we put in 10 miles, we're essentially increasing that distance by $1, or that amount of money by $1.50. So we'd be up around $13.50. And then we can continue on from there. So I'm going to add some magical dots. Just one moment. So there's our little row of dots. They've magically appeared. Isn't that amazing? And now we can connect those dots into a line. So that is transcontinental. Let's look at intercity express now, and I'm going to do that in this funny little red color. And we start at $5 for every $5, or we start no matter what at $5 for this company. And it looks like we add 20 cents per mile. So if we had 10 miles, we'd be looking at adding $2. So then we'd be at $7. At 20 miles, we'd be at $9. At 30 miles, we'd be at $11, and so on. So I'm now going to add those in. Just one moment. So there's our magical little dots for the red line for intercity. And as we can see, the lines are kind of starting to get there, and I know my graph isn't perfect, but we'll pretend it is. We know that given the situation, F is equal to 0.15 D plus 12, and this other one of F is equal to 5 plus 0.2 D, we can figure out if they are eventually going to meet. And the reason why we can figure that out is we can look at the slope. The problem is, between these two equations, we have slope in a different place. So let's put this second equation into that y equals mx plus b format. So we want to have our slope and the x, or the slope and the independent variable to be in the front of the equation versus the y-intercept in the back of the equation. So here's our y-intercept. We're going to shove that into the back. So we could have fare is equal to 0.2d plus 5. So looking at this, we can see that the slopes are different. And because the slopes are different, we can say that these lines are not parallel. These are not parallel. If they were parallel, the slopes would be the exact same. So 15 cents or 20 cents, they would go up at the same rate. But they're not. One equation is going up by 15 cents, the other one is going up by 20 cents. So eventually this second equation, Intercity Express, is going to tell you that if you're traveling for a long, long distance, maybe it's not actually the best situation because you might be paying more than transcontinental. Transcontinental, however, it looks like for at least these shorter distances is more expensive. So based on that, we could eventually say, they're going to cross. So is there a distance for which the fare of the two bus lines is the same? We can say yes, there is. And it says also, give the distance and the fare. So what I would suggest for a problem like this, after we've looked at a graph and played around with that, if our graph doesn't actually end up showing that intersection, make a table. So we've made a graph out to 100. So let's actually I'm just going to change this table up a little bit. Let's say we have transcontinental on one and intercity on the other. So if we had a distance that was added in there, if we started at 100, we're looking at the distance for this first fare for transcontinental. Our distance at 100 is 100 times 15, which is $15 plus 12. Well, I guess, yes, plus 12, which is $27. Our distance for 110 is what? Ends up being $28.50. If we had 120, our amount is going to end up increasing by $1.50. That's how much it increases by every 10 miles. So that means it's $30. If it's 130, it ends up being $31.50. Let's go up to maybe 150 and see if it crosses. 140, we got $33, and 150, we have 34.5. And essentially to find that information, all I'm doing is I'm saying 0.15 times, let's say 130, and I'm adding 12 to it. So that is the fare for transcontinental. So this will end up being 130 times 15, which is $19.50, and we're adding $12 to it, so it ends up being $31.50, exactly what we have in our table. So we're also going to do that for intercity continental. So let's fill in that table magically. So there we go, we have the table filled in, and if we look at this table, we have Intercity Express, which is increasing by $2 every 10 miles. And if we look at this, we end up seeing that at 140 miles, that's where both of the tables end up getting us the same value. So yes, our answer, they do meet, and they end up being the same at 140 miles. Final answer. Play around with this whole concept, see if you can understand how these various problems work, and if you have any questions, as always, please ask. Thank you so much for paying attention, and I will talk to you later. Bye.